My name is Phoebe, and I'm from the community team at Elastic, and we help to organize these events. And I'd love to introduce you to Salar Rahmanian, who is the organizer for this meetup group, the San Francisco Elastic Meetup Group. And Salar will take it away, talk a little bit, and then we'll get started with our presentation with Ami Parat and Sartak Nandi. Salar, go ahead.
Great. Well, thanks everyone for coming to the San Francisco Elastic Meetup. Fun fact about Elastic's San Francisco's Meetup is that it's the oldest meetup group that's globally that was set up to support the Elastic user group, and it was set up before Elastic was a company. That's a bit of history for you. The other thing I just wanted to mention was that if anyone wants to ever do a talk at these meetups, please let me or Phoebe know. Tonight we have two talks for you. One by Ami Parat of Elastic, talking about data ingestion to visualization, and one by Sartak Nandi of Yelp. Before COVID, Yelp used to host our events regularly, so we're very grateful for them doing that in the past, and for them providing such great quality content to our meetups. But I guess, Phoebe, if you agree, we'll get started with Ami Parat with his talk. Ami, shall I pass it over to you?
Sure. Thanks so much, Salar and Phoebe, for getting this together. Admittedly, this is my first virtual meetup. So in the spirit of fun facts, we have sounds like a veteran meetup group with a rookie presenter. So I'm excited to be here today. Before I get going, I just want to say if you do have any questions throughout, please throw them in the chat. Phoebe is going to be monitoring the chat, and she'll jump in and let me know if something has gone unanswered. I'd love to make this as conversational as possible. I have a few slides prepared just to give a little brief overview of what I'm going to go over, but for the most part, we're going to be jumping right into Kibana, and I'm going to show you some cool stuff in the stack. Okay, so we might have all levels of familiarity here with Elasticsearch. So I'll start with our big mission statement, which is search, observe, protect. And these kind of stand for our three pillars here at Elastic, our three big solutions, which is Elastic Enterprise Search, Elastic Observability, and Elastic Security. For those of you who are new to Elastic, Elasticsearch was really designed as a search company. The technology facilitated scalable, fast, and relevant search. And as time went on, the industry kind of found these beautiful avenues for the technology to support observability, enterprise search, and security being the main ones. So today we'll cover mainly kind of in the sector of observability, but also touch a little bit on what goes on inside of Elastic Security. And really what I want to cover is from kind of the beginning of the journey in a cluster, how do we get to the point where we actually ingest data? What do we use to ingest data into Elasticsearch? And once it's there, how do we look at that data? So for those of you new to the stack, we have three primary components, or really four, but three layers to the Elastic Stack. We have the ingest layer, which is where you see beats and Logstash. Today we're going to be focusing a lot on beats. We have Elasticsearch, which is the core engine, and we have Kibana. Now, when Elasticsearch just started, so Salar probably at the first couple meetups with Elastic, I don't even know if Kibana existed then. And I wouldn't be surprised if it did not. And then once it did exist, Kibana was just a visualization tool. It was a way to visualize data. Now it's become a lot more than that. Now Kibana is a fully integrated way to access and manage your data in the Elastic Stack, as well as visualize that data. And it's also the home to all three of our solutions. So today we'll focus primarily on visualization, But keep in mind, Kibana is a lot more than that. And hopefully I'll be able to touch on it a little bit as we go here throughout. So this is a basic ingest pipeline in Elasticsearch. At its most basic form, we have our beats, which are data shippers. They sit on an edge machine. They have some built-in module, some built-in functionality that tells them what kind of data they're meant to collect, and they ship that data directly to Elasticsearch. There could be intermediaries. There could be intermediary data or intermediary places where the data is sent, but for the most part, you can think of beats as you can think of a basic ingest pipeline as beats send data to Elastic, and Kibana can then access that data in Elastic and let us view it. Now, the beats we're going to cover today are file beat, metric beat, and a little bit of packet beat. File beat, the way it works is it finds itself on a host machine, it gets installed, it points to a directory or a file containing logs, and it will start collecting those logs. Now, for different log types, there's what's called a file beat module. A file beat module will say, hey, if I recognize this log type, that's the one I want to collect, so that by the time data gets sent to Elasticsearch, it's already formatted in what we call the Elastic Common Schema. And the Elastic Common Schema is really our way of normalizing data so that the data model is prepared to be searchable, aggregatable, and what that really means is by the time data hits Elasticsearch, you can start your analytics and you can start doing what you need to do. So that's kind of the beauty with Elastic, with the data shippers here. Today, what we're going to focus on is cloud-based logging. So in a cloud-based architecture, we have our Elastic Cloud, which runs on AWS, GCP, or Azure, and it's a hosted kind of infrastructure as a service. On the cloud, you get to deploy an Elasticsearch cluster, your Kibana layer, maybe you have an APM server, your Elasticsearch nodes are all managed by Elastic. What you can do is install a beat at one of your edge machines, and you'll configure it to point to your Elastic cluster, and you're done, and data is getting sent in. And that's exactly what I did today. The only difference is today, I've used my host machine. So on my host machine, we have file beat, metric beat, and packet beat running, and we'll take a look at how those kind of look once data is inside of the cluster. Before we get there, a quick plug for the Elastic community. If you ever want to play around with Elastic, whether you want to spin up a cloud deployment yourself, it's just a couple of clicks and you can try. You always get a free trial on the cloud. And of course, always, we always encourage our users to connect with us on the Elastic community forum. It's a great place to get your questions answered. It's a great place to chat with people, all things Elastic, even for a novice or maybe even an experienced Elastic user. There are good discussions there, and oftentimes any question you might have has likely been answered. And if not, you'll probably find somebody eager to answer it there. So all useful links, if you want them sent out, we can always send them out here or later in the session if you don't get a chance to write them down now. So I'll pause for questions briefly. Phoebe, I don't know if there's anything in the chat that you see.
I don't. Yeah, does anybody have any questions just on kind of this basic overview of Elastic, kind of talking about the stack and how it all works together? This is your prime moment. Just out of curiosity, how many of you are using the stack right now? Feel free to either unmute or answer in the chat. Anyone feel brave enough to answer that question? Oh, great. Michael says he's using it, not using it, using it now. Okay, great. So we've got a few folks that are using it and are probably fairly familiar. Yeah, we could probably move on to the next part.
Cool. So what I'll do is I'll jump here to the demo. And when I say demo, it really is a live environment. Everything is, nothing is, you know, it's all real data. It's all being captured live. Everything we see is going to be captured live. So let me pop that up here. Share my screen. Can everybody see my screen okay? I think actually I want to share just Chrome to make it easier on everybody. Apologies here, I'm getting a little delay. Can you still hear me okay?
Yeah, I can.
Okay, give me just 1 minute.
Right.
Okay, great. Is everybody able to see my Google Chrome and hear me okay?
I can, yes.
Great. So where we're at here is really the home page of Kibana. So you can imagine kind of where we're picking up is we've deployed a cluster, we've instrumented our data shippers, and we're kind of ready to get going. So I touched a little bit on the kind of data that we're going to be looking at. I mentioned we have packet beat, file beat, and metric beat. So first thing I'm going to do is when I open up this left-hand side, you can see that we get a view of our different Kibana solutions. We have some Kibana specific options, we have some solution specific options, and then we have management specific options. So just to dive right into the data, the first thing I'm going to do is I'm going to go here to Discover. Now, the Discover page is a way to get a quick look at the data that's being shipped to Elastic. On the left side, you can see here we have this structure called metric beat dash star. Now, what this is referring to is a metric beat index. An index is the structure that holds data within Elasticsearch. So for this Discover page, what we're looking at is metric beat data. You can see at the top right here, it says we're looking at the last 15 minutes of data. Well, the way metric beat collects data by default is it looks at system processes running, it looks at system CPU numbers running, all kinds of system metrics that you want to collect, and it's going to sample them every 10 seconds. Of course, you can change the sampling time, but in my case, it's running every 10 seconds. So you can see we have a count of documents over time here in this visualization. Now, I could also, if I want, interact with this visualization. For example, maybe I want to change the time value of my search. Maybe I only want to look at this particular interval of time. So I can do a simple drag, and then it's going to update that time view for me. So something you'll notice here on the left side, you get all of the fields within metric beat. By default, metric beat has a slew of system metrics that it knows how to collect, be it just system level metrics. It could be maybe you have Docker running on a machine. The list goes on. And if you're curious, you can go to our documentation and you can read about our metric beat modules. Maybe there's a data source that you want to collect. Chances are we already have a module for that. And again, what that means is if you're using one of our modules, data comes into Elastic and it's already in the Elastic Common Schema. So we can look at particular fields. We can actually analyze fields one by one, and we can actually drill down into individual documents. So if I want, I can click a single document and I can start getting kind of a field to key value information one by one. Now you'll notice there's some empty fields here, like Kubernetes event. What this means is, well, there's a Kubernetes module that I'm currently not using, but if I did have some Kubernetes data, I could enable or disable it. You don't have to leave the fields open. I did for the purpose of demonstration, but you can see all the different metric types that we're able to collect. So just from a brief overview, I can see, okay, I see maybe how much memory processes are consuming, which process is consuming what type of memory, and some good information there. Now, it might be that you want to run, again, some more searches here. Maybe, Discover is kind of a good starting point to the data, because maybe you're not familiar with your logs, maybe you've just ingested them for the first time, or, in our case, we're kind of going over it together for the first time. So you want to try to get a quick understanding. Maybe I'm looking for example, for something related to Docker. Well, here I see I have some process related to Docker, and maybe I want to do a search for anything Docker related. So what I can do is I can actually update my filter here using our KQL, which is kind of, you can think about it as a query language specific to Kibana. And I can say, okay, let's look for anywhere where we find Docker. And let's see if I can get an updated search there. Hopefully this agrees with me. Great. So I used asterisks before and after Docker to say match everything before the word Docker and everything after the word Docker in the field process.executable. But what I want to see is anything related to this executable here, to this Docker executable. And now you can see I have all of these logs highlighted for me. So that's an idea of some quick kind of data navigation. Even if maybe you're not the most familiar with building a visualization, maybe you're not even the most familiar with the data that you're looking at, but again, you want to start getting some quick analysis. Discover is a great place to do it. Now, keep in mind, you also have the ability to look at multiple indices. Again, this is just the metric beat data. I could always change this filter to any one of the few indices that I have. Index patterns that I have in Kibana, and it'll match them for me. You can think of an index pattern as a blueprint for the documents inside of an index. An index pattern defines all of the fields and all of the field types within an index. So what I want to do now is I want to take this data that we're looking at, this metric beat data, and kind of on the fly, hopefully build a quick visualization, kind of ad hoc as we work through it together. So I'll go here to our visualizations tab, and as you can see, we have a whole slew of visualizations to choose from. So the one I'm going to choose is Lens, and Lens is a rather new visualization feature. I believe it came out in 7.7, and it's a drag and drop feature that allows you to take your index, take the fields within that index, and kind of start just moving them around so you can build your visualizations without necessarily knowing, you don't have to be an expert in building, you don't have to be kind of a Kibana expert or even an expert within your data. And this tool can be very, very effective in that sense. Oftentimes, we actually see Lens used as, it can even be used as sort of a data investigation tool because you get to start manipulating visualizations kind of on the fly, and it's a very quick way to do it. So again, and we'll kind of take a look at that now. So again, you can see we have all of our fields on the left side here, and we have this center area ready to start producing visualizations for us, and we have kind of our right side panel, which allows us to determine what kind of visualization we want to create. So I'm going to leave everything as is. And the first thing I'll do is I'll simply take the total number of records within metric beat. And Lens is going to say, okay, well, I'm going to bucket that by timestamp. So I'm going to give you the count of records over a period of time. And I'm going to do it based on a time interval that I think makes sense. And what I'm also going to do is I'm going to provide you a few other visualizations that I think might be helpful to you. For example, here's your overall count of records for the time period you're looking at. But I'm gonna go back to this first suggestion, which is this bar chart. Okay, so then I might want to say, okay, this is great. So now I have the total number of documents being produced over time, but maybe I want to see how many. Maybe I want to start bucketing this information somehow. So I can take a field like process name and I can drag it over. And Lens is going to say, okay, I think I see what you're saying. What you want to see is all of the documents that you're taking over time, and per time sample, you want to see the number of documents per process name. So that's exactly what we have here. So we have Google Chrome document count, we have my terminal process count, and we have the Google Chrome helper. So that's pretty neat. And what I can do as well is I can say, I can add a filter if I want. So I can start creating these kind of global queries that should or should not match. So for example, I can say, hey, I want to see everything such that the process name is not this Google Chrome H or this Google Chrome helper. So if I do that, what we should hopefully see is that we no longer have it in our updated visualization. Great, so we lost that, we have our filter, it's applied, and now you can see we have another process showing, and what Lens does is it'll automatically break things down and give you the top 3. I can increase that number. I can also change the way that it's happening. I can make it by descending, ascending. You can see now that my metric beat my metric beat process is showing. So we're kind of getting an idea of how this works. So what I'll do is I will save this visualization. I do apologize. My computer is working really hard today. So I'm grateful for the work that it's putting in. I'll save a visualization here. We'll say Meetup metric beat visualization. We'll save that. So now what I can do is I can go back to dashboards, and dashboards are essentially pages where you combine visualizations. So if I hop over to this tab on the right, this dashboard that you're seeing is a built-in dashboard for metric beat data, which means when you install metric beat, and this dashboard is set up for you, meaning out of the box, you are getting all of this information. Now you can see I have this host name filter for my MacBook Pro, but of course you can imagine if you're monitoring your infrastructure or maybe some internal systems and you've got hundreds or thousands of hosts, where this could be useful. But I do want to highlight mostly the fact that you are not obligated to create all of your visualizations. In fact, the Elastic team puts a lot of work into building out-of-the-box visualizations, especially with our custom data shippers. The idea is to kind of make this drop and go data shipper, data in Kibana, visualize your data. I'm kind of going back and forth to show you kind of the manual way to do it, but also hopefully how to leverage things that are already there for you. So I'll continue to try doing that as I go on here. If we do go back to dashboards, now these are built-in dashboards. All of these come with Kibana, but I could also create my own. So here I've created a dashboard. I can add I can create a new object. I can add whatever it is I'd like to add. So I can say something like Meetup metric beat visualization, and now we've added that visual to the current dashboard that we're looking at. And for some reason, it's not agreeing with me. Perhaps I did not save properly. I'm going to update the time filter here to make sure that there's not some funky stuff going with the time. Just to make sure we can get our data for showing. Great, so there it is. I added it 4 times. So I'll delete a couple of these. My time filter was set incorrectly, but now we went ahead and corrected it. So we created a nice little metric beat visualization. We're building kind of a custom dashboard as we go. And now, you know, I could drag and drop and size this visual however I want. I can also interact with it. I can hover, I can filter out fields. I can kind of play as I wish. So I'll save this dashboard in case we want to add anything to it as we go.
Ami, I don't know if this is a good time, but there was a question in the Q&A. They were wondering, Michael was wondering if this is only a 7.8 feature. And Michael, I don't know if you want to unmute, but you can kind of clarify that by mentioning which feature were you wondering was part of this release?
Michael.
He said he got the answer. Okay.
Okay. Great. Admittedly, so Lens, I believe, was before 7.8. What I'm showing now from the dashboards, I'm not sure how, you know, what the first release you were able to add a visualization for the dashboard, but it should have been there for quite some time now. But Lens is quite new. Just so thank you for that clarification. Cool. So that's our metric beat section. So now I want to kind of shift gears a little bit. So we'll go back to our Discover page, and we're going to go to file beat now. Now remember, metric beat is taking host level information. File beat is taking information from logs. So it's going straight into log files, or you can point it at a directory and you say, hey, I want it to collect logs. Now, if you have the file beat module, maybe you have like SQL Server logs or Nginx logs or, you know, Apache logs, whatever it might be. We have modules that will say, okay, this is the log type I want you to pick up. Make sure the data is structured appropriately. But in my case, or at least what we're looking at here, these are generated logs, but these are logs that file be forwarded, but I did not provide it a module. So we have, for all intents and purposes, unstructured data. Now you can see that for certain fields, FileBeat did know what to do. So It knows the host of the agent. Of course, it knows what agent type it is, what version it's running. But if we go down here to our message, if we go down, you can see that we have the log file path, and we also have the message completely unparsed. So, you know, from a user perspective, that if these logs were critical to me, I would say, okay, well, how do I structure these? I mean, what do you do if you do have an unknown data source? And there's a few ways to do it. One would be to use what we call an ingest processor. An ingest processor is going to take a data feed, and you're going to teach it what the log structure that's incoming is, and you're going to teach it how to map it to the desired fields and types that you want. One example would be Grok, where Grok, you give it the message structure, and it takes the Grok pattern and converts kind of a raw message into live actionable data. We're not going to walk through that process today, but what I do want to show you is I want to show you kind of a neat trick from the machine learning side, where you can feed in an unstructured document, and machine learning is going to do its best bet and say, hey, I believe this is the structure of what you just uploaded. So first we'll go here, we'll go to our file uploader, and we'll say random logs, and we'll open this. So now the data is being analyzed, and you can see here, these are the raw file contents up top, and below in the summary, we can see how Elastic Machine Learning interpreted those logs. So it labels the individual fields, and based on the log structure above, and then it actually gives you a distribution of field count within documents. So you can actually start understanding what is what here and how it affects your logs overall. So maybe if you do need help picking a data model, you can start doing it based off what machine learning gave me in just one click where I uploaded the file. So that's a neat trick. I've been talking a lot about out-of-the-box modules for structured logs. There's a chance you will have unstructured logs. So this is one way to start navigating that. Now, I also would want to show you how to build a visualization on top of unstructured logs. Because what we did with metric beat, I essentially took existing fields from a metric beat module, and I created something from them out of Lens. But based on what I just showed you, well, how do you take the fields if your message is all in one field? I mean, what if you don't have the fields yet from your logs? So this is what we'll do. We'll go to this vertical bar visualization, and we'll select the file beat index. And now what you can do is you can actually select a filter aggregation. So remember, the filter that we chose before when we were using Lens allowed us to kind of make a holistic search, or even when we were looking at the Discover logs, if you remember with metric beat, it allows you to do a holistic search on a text pattern within a field. Now, if we go back to our logs here, to our sample logs, we can see that, for example, we have this error section. And I see that in the error section, I have some number and then some percent of error. And it looks like it's anywhere between 0 and a little over 4%. So maybe I want to bucket my error. Maybe I want to bucket a visualization on my logs so I can see how many documents are in each section by error percentage. So what I would do is I would say, okay, I know that this is in the field message. I'm going to create a little regular expression that says, hey, I want to match anything with 4%. Now I'm going to add a few more filters, and we'll do the same thing. Oops. We'll do the same thing with 3%. And we'll do the same thing with 2%. And just for fun, we'll do the same with 1. So let's make sure this works. Let's update. Okay, didn't like that visual, so let's make sure we get our regular expression right. Okay, so it looks like that's what it likes. So we'll add a few more here. Again, we're just taking, we're just doing a full text search on a message field from the data. And now you can see on the left side, we have a bucket on the x-axis. We have, hey, this is the message, this is the percentage side that we have, and these are the number of documents per bucket. So we kind of get an idea. Maybe this is like, you know, maybe that percentage value is significant to us, and we want to get started with our visualizations. This is a good place to start. So we can say, hey, we'll say Meetup error percentage visual, and we'll save it. And we'll go back to our initial dashboard. And we can add this just like the previous one. Sahar, while I do that, how are we doing, or Salar, how are we doing on time here?
We're all good for time, if you are.
Okay, yeah, of course. There's one more thing I'd love to cover before we before I pass things off here. So we're kind of building out a little visualization here. It's always nice to have a review of kind of what we've seen. Remember, we built a metric beat visualization with Lens. Now we built a file beat a bar chart on unstructured data after we saw kind of how we could utilize machine learning to get some structure out of that data if we wanted. And now we're just kind of building out a dashboard as we go. So there's one more thing I'd like to show you, and this is kind of data as it pertains to the Elasticsim. So when we say, you know, across logs, metrics, APM, and SIM, everything that we ingest into Elastic lives in an index. And because of that, ultimately, when you're searching, whether you're searching logs or APM data or metrics or SIM data, you know, from the Elasticsearch engine perspective, it has a data type and it has a document and an index that it's looking for, so it can search across all of these data sources relatively easily. So when I jump into the SIM here, keep in mind that, you know, the way that data gets ingested is exactly the same, but the focus of how to seek value out of that data is catered specifically to security data. So what I have is, this is the SIM homepage. Now we have no signals here or external events, because a signal refers to an actual detection found in the SIM. So, admittedly, this is not a SIM demo, but just a way to demonstrate that here at the bottom, we can actually see SIM events, because these events are coming in from PacketBeat, which is, again, running locally. And every single one of these individual data shippers, whether it be AuditBeat or the Elastic Endpoint Security Agent, or WinlogBeat, which is a beat that runs on Windows machine, you can get a breakdown of the type of events that your SIM is picking up. So you can see here the majority of data that I've gathered here in my live environment is network flow data. And again, this was a single install on a host. I configured the cloud ID that I wanted to ship data to, and then I started forwarding data, and that was the lot of it. And now it's viewable from the Elasticsim, and what we're looking at is the Elasticsim homepage. On the side, you can see we have all our security related news, but again, this is all within the context of Kibana, where we have our ability to visualize, go to the machine learning, go through logs, metrics, APM, and so forth. So that's kind of, I know we covered a lot of ground there, but that's the overview I was hoping to give, cover various data sources and kind of how they apply in different places and how you can get started quickly with Elasticsearch. I hope that was helpful. If there are any questions, I'm more than happy to answer. I know there's a lot of ground covered there, so it's always good to ask any question you might have. I'm sure you're not the only one.
Folks should feel free to either throw their questions in the chat, or you can use the Q&A feature, or if you'd like to, you can unmute yourself and just ask directly. If you're going to put your question in the chat, remember to set your to all panelists and attendees so we can all see your question.
And you can always feel free to throw questions in the chat. We'll be monitoring live for the rest of the presentation, so you can always get your questions answered as we go on here. But if that's all we've got, then Salar, I'll pass it back to you, and I appreciate everybody's time.
Thank you, Ami. It was a fabulous talk. Thanks for taking the time. Hope you'll come back and do more talks in the future. Maybe one day in person. Great. Our next speaker is Sarthak Nandi of Yelp. Yelp have been building a learning to rank system using Elasticsearch, and if you look at the last 1 year of the events we've ran, they've done a series of talks about their work, and you can actually see the previous events, their previous talks on the San Francisco Elastic User Group's YouTube page. I'll actually share that in the chat shortly in case anyone wants to have a look. But this talk, I believe, is the next installment of how they're using Elasticsearch, and I'll leave it for Sarthak to tell you all about it. And Sarthak, feel free to tell everyone what Yelp is doing with Yelp is doing, and what their involvement with Elasticsearch is before you do your actual talk. So over to you, Sarthak. Thank you.
Right. Thanks, Salar. Are you able to see my screen?
Yes.
Awesome.
Yep.
Thank you. Yeah, so hi, everyone. I am Sarthak Nandi. I'm a software engineer on the ranking platform team at Yelp. And today I'm going to talk about our Elasticsearch 7 upgrade and some of the challenges we faced and the lessons we learned from them. I was supposed to do this meetup right before COVID hit. And while have been really happy to talk to everyone directly in person, but I'm still glad to be able to share our work that we have done virtually. So let's get started. At Yelp, our mission is to connect people with great local businesses. We have over 200 million reviews. We have millions of monthly unique visitors. And search is a big part of Yelp and a big part of fulfilling our mission. So we have millions of documents in our Elasticsearch cluster. We serve hundreds of millions of search queries every day with support for near real-time indexing. So when you're searching for restaurants, or when you're looking for a plumber, or looking for reviews of your favorite food, or searching for events, or looking at ordering new businesses, or when you see relevant ads, all of this is powered by our Elasticsearch-based ranking platform, which takes full advantage of the customization options offered by Elasticsearch. So we have custom analyzers, custom plugins, custom scoring, custom aggregations, and a customized deployment strategy which fits the infrastructure ecosystem at Yelp. So we were running Elasticsearch 6.3.1, and last year we upgraded to Elasticsearch 7. Now, I'll just give a quick look at our upgrade process because we don't do rolling upgrades, but instead we create a new cluster. We index all of our data to the new cluster, and then we shift the search traffic to the new cluster. So we do this with the help of our proxy, which sits in between Elasticsearch and our indexing and search clients. So when we want to do an upgrade, we bring up the new cluster that runs a new version of Elasticsearch. We index all of the data to it, and then we dark launch this cluster. So what this means is that we send traffic to both the status quo and the new clusters, but we serve results from the status quo cluster only. We still record the results from the new cluster, and we verify those results to make sure that the results from the current and the new clusters match. We also check that there is no degradation in timings. After this verification, we live launch this new cluster by steadily shifting traffic and serving results from the new cluster. Once we have shifted all of the traffic to the new cluster, after that, we decommission the old cluster. So we faced some challenges during our Elasticsearch 7 upgrade. These related to master discovery, negative scores, and upgrading plugins. So let's start with master discovery. At Yelp, we launch each Elasticsearch node on a separate AWS EC2 instance. The instance is configured using Terraform and Puppet. So in case you're not familiar with these tools, Terraform is a tool that lets you maintain your cloud infrastructure as code. And Puppet is a tool that lets you automate the configuration of the instances. So we specify our EC2 instances, autoscaling groups, AMIs, tags, etc. in Terraform. And we apply Terraform. So after AWS brings up the instances, Puppet runs on those instances. It adds the Elasticsearch binary, installs the plugins, builds and adds the Elasticsearch configuration, and finally starts the Elasticsearch service. So we have different autoscaling groups for master, routing, and data nodes. For service discovery, we use SmartStack at Yelp. So in this system, we have Nerve run on every node and register the node in Zookeeper. Synapse then reads the registration information in Zookeeper. For Elasticsearch, we have a Synapse discovery plugin, which reads those populated host names and lets the nodes discover other nodes in the cluster. Now, when you have a multi-master system, you need to avoid split brains. Before Elasticsearch 7, this was done by providing a minimum number of master nodes. So let's say that you have 3 master nodes in your cluster. You would set minimum master nodes to 2 so that one master node cannot form a different cluster. Now, this worked, but there was one problem with this. Let's say that you increase the number of master nodes you have. Let's say that you go to 5 master nodes. Now, if you forget to change the minimum number of master nodes, you again have the split brain problem because 2 nodes can form a different cluster. So Elasticsearch 7 remedied this issue by adding initial master nodes. So now you provide the exact node names for the master nodes, which will form the cluster. So now even if you add new nodes, they can't form the cluster because they won't be in the initial master nodes unless you have specifically added them. But this presents a problem for us because in our system, we don't identify the individual master nodes in advance. So how do we tell Elasticsearch these initial master nodes? We first looked at a tool to specify the initial master nodes. So this would have been straightforward, where a developer will provide the master host names to a tool, and this tool will then update the configuration on the cluster. But this does add an extra manual element, and we would prefer that our Elasticsearch launch is as simplified as possible. So we looked at other solutions, and this solution was proposed on Elastic's forums. So the idea is that you use a temporary master node just for bootstrapping. You create a single master node outside autoscaling groups. You bootstrap the cluster using this node. And once the bootstrapping is complete, you remove this node. But because we use Terraform to launch new nodes, and also because we have Puppet for automatic configuration, this was non-trivial. And also it was non-trivial to figure out how and exactly when to remove the node safely. So this is what we finally went with. We put each master node in a separate autoscaling group. So this let us define different tags for each master node, because in AWS, you define tags for the autoscaling groups. So we added a different node name tag for each autoscaling group, and we also added all of the node names in a different tag for all of these groups. Now, Puppet can run on each node. It can read these autoscaling group tags, and then it can build the configuration, adding the right node name as well as the initial master nodes. So now when all of the master eligible nodes come up, they are able to bootstrap and form the cluster. And this happens automatically without any extra manual work. Now let's talk about negative scores. To give you a quick look at our scoring flow, we heavily use learning to rank at Yelp, as Salar had mentioned earlier. So we have multiple features which can come from multiple different sources. They can be computed in our native plugin. They can be computed from the painless script, or they can come from a Lucene derived expression or from the Elasticsearch query. These features can also be used to compute other features. And finally, we use the features to compute the final score in a model. Now, these models used in learning to rank are trained using machine learning, and they may output negative scores. This is a bit problematic for us now because Elasticsearch 7 uses Lucene 8, and it does not allow negative scores. The reason was that when the Lucene implementers were working, especially on the Warn logic, they discovered that it was a bit difficult to support negative scores with it. And so they decided it was better to just have support for positive scores. For us, it presents a challenge, but because all of our scoring happens inside our scoring plugin, we try to handle this inside our scoring plugin itself without having to change our models. So we first looked at boosting our scores. This would have been trivial where, so you find the smallest score you get, and then you boost all of your scores by this value. So let's say that the minimum score you can get is -100. So you would add plus 100 to all of your scores. Now this works for the final score, but with learning to rank, we output feature scores as well. And also these features may be reused with nonlinear functions. So if we boost the scores, the boosting won't preserve the ranks. And this applies to using sigmoid as well. There's another problem with boosting scores. Elasticsearch and Lucene use float, and so there is an especially pronounced loss of precision when you boost by large numbers. So take this as an example. Let's say that you have scores of 1.1234567 and 1.123457. These are two different scores, and you can easily rank documents that have these two scores. But if you boost these scores, let's say you boost them by plus 10. Now both of these scores become 11.123457. And now you can't rank these documents correctly as you could before. And the problem just becomes worse as you boost by higher numbers, if you boost by 100 or if you boost by 1,000. So we first try to handle the issue with computing the features. So if a feature was negative, we set its value to a placeholder. This has to be a high positive number, which is not going to be computed as a normal score. So we just took float.max value. Now, when we were using this feature, we first checked if its value was equal to this placeholder, which would indicate that the actual value of the feature was negative. And then we could recompute the score and use it. This worked fine, but for features which are complex and if they are recomputed multiple times, this affects the performance because this computation is done per document. So we looked at other solutions. What we wanted to do was that we needed a way to tell us that a feature had a negative score originally. So even if we, so let's say that a feature had a negative score, we could multiply it by -1 and make it positive. And if we have the way to say that its original score was negative, we can multiply it by -1 to get the original score back. So we have only a few features that output negative scores. So what we did was we added a negative indicator feature for each of these negative features. So now these negative features are computed twice, once for the actual feature and once for the indicator feature. So this is still twice, but it is better than the multiple times in the previous solution. This is how it works. So when we compute the indicator feature and the value is negative, we set the indicator feature to 1, otherwise 0. And when computing the actual feature, we multiply the value by -1 if it is negative, so that the value becomes positive. When using the feature, we first check the indicator feature to check if it is 0 or 1. If it is 1, we know now that the feature was negative, and we can multiply the actual feature's value by -1 to get the original negative value. This takes care of the feature scores, but we can't do the same with output from the model because we need to return a single score. So we decided to boost the final score from the model, which brings us back to the problem of loss of precision. Now, a document that has a very poor score is probably not relevant to the user. So we tried setting a threshold and setting scores below this threshold to 0. So now we only have to boost scores by this threshold. This is an example of how it would work. So let's say that you have scores ranging from -1,000 to some positive value. Now, if you boost your scores by the minimum score trivially, so you would boost by +1,000 in this case, you would get scores ranging from 0 to 1,000 something or more, with the scores of -1,000, -300, -80 becoming 0, 700, 920. Now, boosting by 1,000 means that you can lose 3 decimal places of precision. But instead, if you set a threshold of -50 and you just set the scores below -50 to 0, So in this case, the scores of -1000, -300, -80 would be set to 0. And now we boost the remaining scores by +50. So we are still boosting, but the loss of precision would be much less as compared to boosting by +1000. If you are able to set a higher threshold, like -10, this becomes even better. So now this makes our scores positive while reducing the loss of precision for the documents that are relevant to the user. We do completely lose the ranks of the lowest ranked documents, which were negative, but it's fine because we have a lot of documents that are ranked higher, which are more relevant to the user, and the user will probably not see those lower ranked documents at all. Now let's talk about upgrading plugins. So I've mentioned some of the Elasticsearch plugins that we use at Yelp. We use Synapse Discovery plugin to let nodes discover other nodes in the cluster. We heavily use Learning to Rank plugin for scoring with our machine learning models. We have a custom scoring plugin, and we also have a map type plugin, which provides fast doc value lookups for map data. Now, API changes in Elasticsearch and Lucene can break these plugins. Often these changes are trivial, for example, a change in a function signature, but other times these changes can be more complicated. And this was the case with our scoring plugin, which uses custom similarity. This is how the similarity interface looked like before Lucene 8. There is a score method that you override to generate a custom score. There is also a compute slop factor method. This accepts distance as a parameter, and you can use this method to penalize documents for phrase queries in which the terms from the query are far away from each other. So for example, if you're searching for quick fox, you want documents that contain quick fox higher ranked than documents that contain quick brown fox, which should in turn be ranked even higher than documents that contain even more words between quick and fox. This is what the compute slop factor method lets you do. This is how the custom similarity interface looks like in Lucene 8. We still have the score method, which you can override to generate the custom similarity score, but the compute slop factor method has been removed. It has been hard-coded to 1 by 1 plus distance instead, because Lucene maintainers required the slop factor to always decrease with increasing distance. Now, among other things, our custom similarity was overriding the slop factor computation. We were setting it to 1. Now, I just explained how the slop factor is used to get more relevant documents for phrase queries. So it might seem counterintuitive that we are overriding this to 1, but it worked for us because our phrase queries use less number of terms in most cases, and also because we didn't have that many phrase queries. So now it becomes a problem for us because learning to rank models that we have, they use the word score as well. And these word scores now change because of the change in the slop factor. So what to do now? There was no clean way to override this, and we didn't want to retrain all of our models. So we ran all of our queries through both Elasticsearch versions, and we compared the results from the queries. We found that for most of our queries, we either are not using phrase queries, as I mentioned before, or we found that other parameters other than the word score were contributing more to the final score. And so as a result, the change in the ranks wasn't either there was no change or there was a minimal change in the ranks for most of the queries. We still don't know how the search metrics would look like for those queries though. So we rolled out our changes in production behind an experiment to a small set of users. We gathered metrics from these users and we made sure that there was no significant degradation in search quality. Only after that, we rolled the cluster out to all of our users. So these were some interesting challenges. And when you have interesting challenges, you also have some takeaways from them. For us, the biggest takeaway was that customization comes at a cost, and not just the cost of building the customization, but also the cost of maintaining it across adding new features and across version upgrades for Elasticsearch. But we constantly evaluate the cost of customization and the trade-off. So for example, in the case of the slop factor customization, we found that we didn't need we found that the customization was not providing enough business value for the cost of maintaining it. And so we dropped the customization. Also, if you have scoring plugins, you should be careful when you're doing version upgrades. You should run all the different queries you have and then compare the results from both the old and the new versions. This was how we evaluated the changes for our negative scoring, and this was how we found the change in scores due to the slop factor change. So if you do run into a situation like ours where it is difficult or it is not feasible to make the change to maintain the exact same ranks, it is good to have the capability to do a phased rollout where you roll out to a small set of users and you verify that the search metrics do not degrade. Lastly, when you're using custom plugins, you should always benchmark the plugins to make sure that there is no degradation in the performance, because especially in the case of scoring plugins, there is code that is run per document. And so small changes in the plugins can have a huge impact on the performance and the timings. If you do find a degradation in performance, profiling helps a lot to figure out where exactly the degradation is happening. And with that, I would be happy to take any questions.
If anyone has any questions, you can go ahead and unmute and ask directly, or you can drop them in the chat.
Also, we are active on social media and we post about our work on our blog, not just related to Elasticsearch, but a lot of different work that we do at Yelp, whether it's streaming or it's UI stuff. And we have also open sourced a ton of code on GitHub. So please do check it out if you're interested.
Just out of curiosity, I'm sorry, just out of curiosity, I just want to check in with everybody just to get a sense of the content here. Is most of this feeling useful to you, or are you feeling like maybe this is a little more advanced or maybe not advanced enough? I'm just would love to get a handle on where this information is falling for you. Feel free to drop in chat or just unmute. Crickets, tumbleweeds. Okay, well, if anybody does want to share any of that, please feel free to. We also have, I dropped earlier in the chat, if you scroll up, a bunch of links to help folks if you're looking for more information. We have a forum where you can ask technical questions. It's discuss at elastic.co. And then just various other links getting started. We have free training available, and we have a very vibrant YouTube channel, as well as a Slack workspace that you are welcome to join the conversation there. And then if you have any questions, please feel free to email us at meetups@elastic.co. And we are always looking for speakers. So if anybody feels motivated to come and chat with us about how you're using Elastic, or share maybe some of the challenges you've had or some wins, we'd love to feature you in a meetup. So please reach out to either Salar or I. We'd be happy to help get you set up.
Big thank you to both speakers. Both talks were excellent. And Sarthak, thank you to you and Yelp for continuing to support our meetup so well. Hope to see more of Yelp in the coming months.
Yes, thank you so much, Ami and Sarthak. It's really valuable to have this information shared out in our community. Both talks were great. I will be sending out the recording of this meetup to our YouTube channel and sharing it with Salar to post on the Elastic San Francisco User Group YouTube channel as well. And I will follow up with everybody in an email that will give you links to this and some other resources. So look for that coming soon.
Last but not least, thank you to Phoebe and Elastic for facilitating and supporting our meetup group so well. Thank you so much.
Of course, my pleasure. Yeah, it was great meeting you, Sarthak. And also, this is, believe it or not, the first time that I've gotten to see Salar in person because our company is fully distributed and I am located in Boulder, Colorado. So unfortunately, this is how we get to meet in this day and age. But hopefully someday soon, right, Salar?
Yeah, absolutely, yeah. We nearly were supposed to meet at Elasticon, but then you went to a different conference.
Yeah.
And then COVID hit after that, didn't it? So.
Yeah, exactly. We just had bad luck.
Yeah.
But soon, one of these days. If anybody wants to ask any questions, we'll hang out here for a few minutes and keep the line open. But if not, we'll go ahead and close it. And I hope all of you have a wonderful evening. And thank you so much for giving us your attention for the last hour or so. And I hope you have a wonderful evening.
Have a nice evening, all. Thanks again, Phoebe.
Thank you.
Ami and Sarthak. Thank you all.
Thanks,
Have a nice evening.
Thanks a lot.